Okay, now we're going to look at section 7.2. 7.2 has a little bit more to think about in it. Okay, so let's write two systems of three equations. So there's two parts to this one. We are going to solve three equations for three variables, and then we're going to make a quadratic from the three equations. From three equations. So let's do the first part. To solve, and I'll write these out. The first one is 2x plus 3y plus 7z equals 13. Now, you want to have enough space here. If you're down near the end of the page, middle of the page might be okay because you write smaller than me. But I ended up doing a full page for this, and that's what I'm going to do here. So you may want to make sure you have room or be ready to move to another page if you finish. But let's see how we go here. The second one is 3x plus 2y minus 5z equals negative 22. So an x and y and a z. The third one is 5x plus 7y minus 3z equals negative 28. Essentially, we solve these just like we do with the two equation ones. It's just a little bit more work to do. So I need to eliminate one of the variables. And it's hard to sometimes tell which ones because I could choose any of them, but just looking at the numbers, the easiest ones to work with look like it's going to be the x's there. Because they're smaller numbers and they're all the same sign. It could help that these are different signs for some, but the fact they're smaller numbers makes them a little bit easier to work with. So what I'm going to do first, I'm going to take the first one, and I'm going to do this. I'm going to multiply it by the number 3 so that I can I'm going to make these both 6x's so I can subtract and get rid of the x's on them. And I'm going to take the second equation and multiply that by 2. So that first equation now becomes 6x plus 9y multiplied by 3, multiplied by 3, multiplied by 3, 21z multiplied by 3, 39. I'm going to take the second one, I'm going to multiply everything by 2. So that's 6x plus 4y minus, minus 2 times 5 is 10. I don't know why I put a 3 there, but let's make it a 10. 10z equals negative 44. 2 times the negative 22. So having done that, by multiply that one by 3 and multiply that one by 2, I have these the same, so I can subtract them. Because 6x take away 6x, the x's are gone. So I have 9 take away 4, which gives me 5y. 21, negative and negative makes it plus, so it's plus 31z. And 39 plus 44 gives me an 83, 70, 83. Okay. I now have a 2-variable equation. I need another 2-variable equation, and then I can work with those just like we did in the last section, in 11.1. So I'm going to do this again here, but again, now this time I still have to get rid of the x's. Since I chose to get rid of the x's here, I have to do it again. I can't move to the y's and z's. I can't get rid of those, or else I won't have a y and z equation. So I have a number of choices. I can multiply this one by 5 and this one by 3 and get 15 x's and cancel them out. Or I can multiply this one by 5 to get 10 and this one by 2 to get 10 and cancel those out. I have to use this one for the other one because I use these two together. I just have to pick one. It's really your choice. So in my case, I like to use smaller numbers. I'm going to make this one 10 and this one 10. So I'll use number 1. I'm going to do number 1. Multiply all those by 5. And then the third equation, I'm going to multiply that by 2. Because that will allow me to get 10s here. So 5 times each of those numbers gives me 10x plus 15y plus 35z equals 65. So let me double check those. 5 times 2 is 10, 5 times 3 is 15, 5 times 7, 35, and that's 50 and 15, yep, that's 65. Then I'm going to multiply this one all by 2's. 10x plus 4y, 14y. 2 times 7 is 14, 2 times negative 3, so it's going to be negative 6z. And then 2 times negative 28 will give me negative 56. And again, I need to subtract to get rid of the 10x. Now when I subtract there, I'm going to get those canceling out. 15 take away 14, just simply 1y. That's going to be helpful. 35, well, minus and minus is plus, so we get plus of 41z. And then, oh, that's another plus, that makes 56. So when we add those up, we get 121. Make sure everyone's caught up and you're following. So now I have a yz equation and another yz equation. Let's put them together. 5y plus 31z equals 83. Y plus 41z equals 121. And I went down here because there was so much there. I'm going to change them over on this side now. Here, if you think about, all I have to do is make that 5y and subtract it, and we get rid of the y's and we'll know what z is. So I can keep this one as 5y plus 31z equals 83. Now here I'm going to take this one and I'll multiply it by 5. 5 times y is 5y. 5 times 41 is 205. And 5 times 121 is 605. Now, if I had multiplied by negative 5, I'd have negative, negative, and negative, and I just subtract each one. But I can do the same thing with subtracting here like this. So, 5 minus 5, gone. 31z minus 205 is negative 174z. 83 take away 605 is negative 522. Sure you caught up with me there. And then when you divide both sides by that negative 174, it comes out to a really nice, simple z equals 3. All of that and all those big numbers, and got a simple basic 3 for the z. So that tells me that in each of these cases, these are a 3. Now we need to find the y and the x. Well, let's just go back to one of these two problems, and this one's already set up to make it easy. Y plus 41, and the z is 3. Now we can solve for the y. Y plus 123 equals 121. Subtract 123, and y is equal to negative 2. So I now know this, and I now know this, and now we want to find the x. So, same thing, let's come back to one of these and let's plug in the y and plug in the z. This one looked like the easier of the problems, so I'll use that one. So I'm going to do 2x plus 3 times negative 2 plus 7, oops, so z, too many of these crossed ones, times 7 times 3. So if y is negative 2 and z is 3, then putting them in here and adding them and then subtracting from the other side, I should be, divide by 2, I should be able to get that x. 2x minus 6 plus 21 equals 13. 2x plus 15 equals 13. 2x equals negative 2. Whoops, bring it so you can see it. Multiplied these, and added them. And then now subtracted 15 from both sides. Oh, divide by 2 and x is negative 1. So that tells me I have negative 1, negative 2, and 3. So let's notice and think about a couple of parts of this. Notice I put my answer in parentheses. Saying x equals, y equals, and z equals is not correct. The reason for that is that back up here when we have these 3 original equations, those are actual equations in a 3-dimensional plane. You have your x and your y, and you have a z, like the depth part of it. all three of those planes meet at a particular certain point, and this is the point where all three of them meet at. That's the goal. You're trying to actually find that point. And as a result, you have to write your answer in that form, because it's an x, a y, and a z that identifies in three-dimensional space. It identifies where that is. So your answer has to be in that form. Don't give me x equals, y equals, and z equals, because I'll take a point off your test. So I insist on seeing it in that form. Okay, that's part one, and that's a pretty good example there of how to take all three of these, break them down so you get two variable equations, and then use that as normal to solve for those two variables, and then solve for the third variable. Let's look at the second part now of this type of problem. Oh, and what I should do is come back here and say, this is the first of 3 pages, page 1 of 3. So now we're going to do 7.2. Page 2 of 3. Because I have 2 examples for this one. We'll see if I think we can get through both of these now, when we have enough time. Make a system of equations into a quadratic. That should be quadratic equation, but I guess I'll write equation underneath it. So that's what we're going to do. We're going to take a system of equations, and we're going to turn it into, into this. By a quadratic, I mean this. Y is equal to a x squared plus bx plus c. Now, you're used to seeing these. Y equals 5x squared minus 2x plus 7, for instance, anything like that. And you could graph that, you could solve for dx, you've done those things before. Before now, you haven't actually figured out the a, b, and c in order to make it. So I'm going to give you 3 equations. Actually, all I'm going to give you, this is part 2. So I'm going to give you a little table of values. So I'm going to tell you that when x is 1, y is 264. When x is 2, y is 196. And when x is 3, y is 114. So when I said system of equations, that's actually the second step. We're going to start off with a table of values, and we're going to turn that into a system of equations, and we're going to use that to find the a, b, and c. So here's how we're going to do that. Right now for this one, x is equal to 1. In this one, x is equal to, ooh, I made a little mistake. Come back to where it says 2 here and change that to 3, please. And that 3 and change it to 4. So when x is 1, we get 264. When x is 3, we get 196. And when x is 4, we get 114. The fact that the 2 is missing doesn't really mean anything. You know, I could have chosen numbers -17 or positive 8,000, and as long as I know what the y is, you could still do this process. But I won't give you numbers like that. We'll stick to basic numbers. So I'm going to use this part. Notice I put this here and I did it on purpose. Up above here, I'm going to rewrite that. Y equals ax squared plus bx plus c. Well, we know 2 things right now. That when x is 1 here and here, we know that the y is 264. So I'm going to write that here. 264 is equal to a, 1 squared, plus b, 1 plus c. Or a plus b plus c is equal to 264. When x is 3, we know that the y is 196. So I'm going to say 196 is equal to a, 3 squared, plus b, 3, plus c. I'm going to do it again with 4. When x is 4, we get 114. A is 4 squared, plus b times 4 plus c. So they're all 3 separate ones, but they're related because the a for each of these has to be the same. The b for each of these has to be the same, and the c has to be the same. So This part here, I call all of this step 1. You're given this, you have to make those. So step 1 is to make those. For step 2, we're going to take this and simplify it. Okay? So I'm going to say that A plus B plus C is equal to 264. All I did is did the 1, but I like having it with this over here. I could have said 264 equals that, it's just easier to work with here. So I'm going to do the same thing here. 3 squared is 9, so it's 9A plus 3B plus C is equal to 196. And for this one, it'll be 16A plus 4B plus C is equal to 114. That's step 2, where you simply multiply them out and give yourself 3 equations. This is where we were before. Now we have just a system of 3 equations, we just have to solve them, which, as you saw, is long and involved anyway. But what we're doing is we're getting a system of 3 equations, but you have to make your own equations. So I give you just enough info that if you do this, you can get the 3 equations. Now we're going to solve for A, B, and C by solving a system of equations. It really helps that you have A and B and C, because now I can choose with whatever I want to eliminate. I can choose to do that by just multiplying one of these by making this a 9, or making this a 3, or I'm making this 16, or making it 4. Actually, I got the C's here. I could probably cancel something out there. And you know what? Right there, we've got something to work with. I don't have to multiply anything. I can do this one, subtract this one, and the C's will cancel. I can do this one, subtract this one, and the C's will cancel. So there's a little like technique trick that makes this a lot easier. You don't have to do any multiplying to change the equations. So watch how I'll do it. And this is actually step 3 now. And I'm going to put a little line here because I'm going to do it twice. I'm going to do this one, subtract that one. 9A plus 3B plus C is 196. And I'm going to subtract A plus B plus C equals 264. And then I'm going to do the third one minus the first one. 15A plus 3B plus C equals 114. Minus A plus B plus C equals 264. And then subtract. 9 minus that, that's 8A. 3 minus 1 is 2B. And that's equal to negative 68. 16 minus 1, so we've got 15A. 3 minus 1, minus a B, so it's going to be, did I do something? No, I didn't. Oh, you know what I did? I knew something was off. I did 16, and then I went up here instead of there. So if you copied from what I did, please make that a 4, because I knew there was something wrong with that being a 3. So 16, 4, and C, should always double check those. I got the 9, the 3, the 196, 16, 4, and 114, and both 2, 6. Okay, now it's better. 4, take away one of them, is going to be plus 3B. And the C's cancel out, and I get negative 150. System of 2 equations. So now I have these 2 to work with. So if I didn't have it where all of them were C's and I could just subtract like this would be a little bit of a harder problem. So it's really nice that in all of these, whenever you do these type, you're going to end up with that for one of them if you have a 1 for the X. So hope that I give you a 1 on the one in the test, because then that makes this a little easier. Now I have these 2. Let's put them together and let's do something with them. I have to decide, do I want to get rid of the A's or do I want to get rid of the B's? I'd say with a 15 there and an 8, this is probably going to be easier. So I'm going to, if I multiply this one by 3 and this one by 2, then I'm going to get 6B and 6B, and I can subtract it, and it's much easier. So that's 24A plus 6B equals negative, 8 times 3 is 204. 88, yeah, 200, no. Yeah, 204. And here, 2 times each of these gives me 30A plus 6B and negative 300. Make sure I got these numbers right. Negative, that's also negative. Okay, I think I'm good with that. This take away that gives me negative 6A. These cancel out. And here negative 204 plus 300 gives me a 96. When you divide both sides by that negative 6, you get that A is negative 16. I'm going to run out of space, so I'm going to write a little smaller here. But follow with what I did here and make sure you recognize that you use these to get two variable ones, and then you work with 2 variable ones to get one of the variables. Now that we know that, we have to get we know the A, now we need the B and the C. So let's put that back into either one of these. Probably easier to put into that one. So I'm going to do, and this is step 4. Step 4 is going to be to get the B and the C. Okay, I guess just the B first. All right, step 3, step 4, okay. So I'm going to do negative 16 in here, so it's going to be 8. Negative 16 plus 2B is negative 68. And then it's just calculating it out. Negative 128 plus 2B, negative 68. Add that over here. 2B is 60. Oh, so B is 30. So we now know A is negative 16, B is 30. We just need C. So call this step 5. So A plus B plus C is equal to 264. I chose of the 3, since I have A and B and I need C, I need to use one of these 3 up here. And it's so much easier to use that one because we don't have any multiplying to do for anything. So that's going to be negative 16 for the A, plus 30 for the B. So let's solve it. That's 14 plus C. So C is 250. Okay. So you've got A, you've got B, and you've got C. Let's come back up here and look at what we do with them. We have A, we have B, and we have C. We're going to just simply put A, B, and C in there. So the most room left is down here. So we'll do y equals A is negative 16x squared, B is 30x, and C is a positive 250. Okay, here's the filled out thing. I will bring it back up a bit so anybody who's copying the bottom part can see. So there's a number of steps involved here. But after the first step, the rest of it is all just solving a system of 3 equations, which is hard, but the more you do that, the better. You still got the concept, the idea of how to do those. You just have to be careful because it's a lot harder with 3 than it is with 2. The first part of it is the only truly new thing here. You have to recognize that whatever value the x is, you can put that in for the x as long as the y value is the corresponding one in the table. Okay, since this is brand new and involves so many things, let's do one more. This will be page 3 of 3. So 7.2, page 3 of 3. And all I'm going to start with is a table of values where 1 is 31, 2 is 44, and 3 is 49. And the unwritten directions here are write a quadratic. So in fact, I'll write that up here as write a quadratic equation. So remember what we're looking for is y equals ax squared plus bx plus c. So that's our goal. and we're going to use these three first off. So that first step, in fact, remember, put the x's in here and the y in there. I'm going to do it, but I want you to write it down first. Using the 1, 2, 3 and 31, 44, and 49, write these out with the ones in here and the y's in there for step 1 of this. And then we'll do step 2. And we'll do 3 of these, 1, 2, and 3. That means the first thing you should have done was and now make sure you do the other 2. It might help, as I see one person doing, to simply put the totals first, so that sort of reminds you you're going to use each one of those, and then you put B in there for those. This time it really is 1, 2, 3 instead of 1, 3, 4, but it doesn't really change anything on the way this is done. As you're finishing it up, see that you got to this place where if you put those numbers in and multiply them out, you get these numbers. 4, 2, and 44, 9, 3, and 49. Okay, now the next step is to use them. So when you look up here and see what I have next here, right, 4, 2, C, and 44. So I'm taking the second equation and subtracting the first equation because that will enable me to get rid of the C's. They will go away. So 4 minus one of them is 3A, 2 minus one of them is just a B, and that equals 13. But I have to do it again. I used the second equation and subtracted the first. Now I'm going to use the third equation and subtract the first one. Nine take away 1, it looks like I've got 8A. 3 take away 1, I've got a 2B here. 49 minus 31 is 18. So, again, a reminder that when you have no coefficients with the A, B, and C, then it becomes really useful for you. All of them have a C, so I just do that one minus that one, and I get rid of the C. This one minus that one, I get rid of the C. Now we have these two basic equations, and now it's back to the normal two systems of equations that you've done before. You're probably a lot more comfortable with that than the 3 equations, but now you can work with that. So when I look at these, well, actually, I could multiply these and make them 24s, but why do that? Here's a 2b, all I have to do is make that 2b and the b's go away. So I'm going to multiply this one all by 2. So I get 6a plus 2b is 26. And then I'm going to have this one, 8a plus 2b equals 18. And here's where all I have to do is subtract that. And I'll figure out what the a is, because 2 minus 2, those go away. 6 minus 8, that's a negative 2a. 26 minus 18 is a negative 8. Divide by negative 2, and a is equal to, oh, wait a minute, that's positive 8. 26 minus 18 is a positive 8. Now, 8 divided by negative 2 is a negative 4. So we now know what a is. Now let's figure out what b is, because if we know that's negative 4, I can put negative 4 in either of these. That was easier. I'm going to do that right over here. 3, negative 4 plus b is equal to 13. Negative 12 plus b is equal to 13. Add 12 to both sides, b is 25. So I took advantage of the fact that these b's were close enough that I don't have to change both of them, I only have to change this equation. So making that into a 2 allows me to get rid of the b's, solve for the a, plug the a in, solve for the b. Now we need the c, and once again this one becomes very useful because we now know a and b, so it's really easy to work with that. Okay, so I'm going to do a is negative 4, plus b is 25, plus c is equal to 31. So that's 25 minus 4 is 21. Subtract it from both sides. So c is equal to 10. And this is where you put them back in with the y equals ax squared. Because what we're trying to do is y equals ax squared plus bx plus c. We now know the a to go here, the b that goes here, the c that goes there. Y equals negative 4x squared plus 25x plus 10. Okay, so let's review these steps. I didn't write step 4 here before, so I'll do that now. I guess you call that step 5. So let's review this. Given just the table, you can use the y and the x's in these places to set up an equation. Same with this one, 44 and 2 is just more complicated. And then 3 and 49, 3 is in here and equals 49, and it works out to that equation. And then it's solving 3 equations by making 2 of them, and then solving these to figure out what just one variable is. Let's make that so it looks like a real A, sort of. And then the rest of it becomes easy algebra. You've done this many times before when it's a 2. When it's 2 variables, you've done it many times. It's when it's 3 variables that's harder, but 3 variables just have to be broken down into 2 variables, and then you've got an easy one by eliminating something. Okay, any questions about how to do this where you're making a quadratic? Okay. So remember, for this section, there's really 2 major things. One of them is to solve a system of 3 equations. And then second is to take a table and go through all this work to get you down where you're saying what the quadratic is.